Welcome to the Mathematics in my channel. Today we are going to solve another interesting integral. The question is show that minus 1 to integral from minus 1 to 0 natural log raised to the n power of x plus 1 over x dx is equal to minus 1 to the n plus 1 power theta of n plus 1 gamma of n plus 1. Well, how to begin? Okay, first I am going to take our integral. This integral is equal to I, and then we can write I is equal to, now I am going to take a substitution. So if we take minus u is equal to natural log of x plus 1, then we can isolate the x plus 1. So x plus 1 is equal to e to the minus u. Now differentiate, so dx is equal to minus e to the minus u du. Okay, now we can plug in here. Now here lower limit minus 1, upper limit 0. When we change the limit, we know here infinity and upper limit 0. Then log of x plus 1, we know minus u, so minus u to the n power. Now dx is equal to minus e to the minus u du over, now x is equal to e to the minus u minus 1. Okay, now we can change the lower limit and upper limit. When we change the limit, this minus get cancelled, so we can write here 0 to infinity. Now here minus 1 to the n power u to the n power sorry, u to the n power, here e to the minus u over, now I am going to take minus sign as a factor, so here minus and here 1 minus e to the minus u du. Okay, then here minus 1, here minus 1 to the n power, so minus 1 to the n plus 1 power, integral from 0 to infinity. Now we have u to the n power here we have e to the minus u over 1 minus e to the minus u du. Okay, now instead of this part we can take a series, so we can write minus 1 to the n plus 1 power, integral from 0 to infinity, here u to the n. Now instead of this we can write infinite sum, k is equal 1 to infinity e to the minus ku du. Okay, now we can write this segment notation outside of the integral sign, so we can write minus 1 to the n plus 1 power sum of 1 to infinity, integral from 0 to infinity u to the n e to the minus ku du. Okay, then again we can take a substitution. So now if we take t is equal to k times u, now dt is equal to k times du. Okay, now we can plug in here, so here minus 1 to the n power infinite sum 1 to infinity, limit also 0 to infinity. Now e to the minus ku, so we know e to the minus t, and here u to the n, u is equal to t over k, so t to the n over k to the n, and here the du is equal to 1 over k dt. Okay, then we can write I is equal to here minus 1 to the n plus 1 power, so here minus 1 to the n plus 1 power, and here we know k to the n k, so we can write k to the n plus 1 power. So we can write here k is equal 1 to infinity 1 over k raised to the n plus 1 power, integral from 0 to infinity e to the minus e to the minus t, here t to the n, so e to the minus t to the n dt. Okay, then here minus 1 to the n plus 1 power. Now this is familiar with us, also this is familiar with us, because we know this is equal to theta of n plus 1, and here we know this is equal to gamma of n plus 1. Okay, if you like this video, please subscribe this channel. Thank you for watching.